안녕하세요. 지광섭입니다. 이 강의는 저희 대한토목학회 해상풍력 해양플랜트 위원회 기술 강좌이고요. 올해 첫 번째 강의가 되겠습니다. 그리고 이 강의 이후에 오늘 오후에 또 두 번째 무료 강좌가 또 있습니다. 오늘 두 번째 무료 강좌는 이제 저희 해상풍력 설치 과정에서 발생할 수 있는 그 국내 선박법의 카보타지 규정에 대해서 어떤 법리적인 것을 고려대학교 해양법 연구센터하고 같이 공동 강의를 하게 됩니다. 또 관심이 있으시면 들어오시면 좋을 것 같습니다. 그리고 오늘 강의는 총 이제 한 128분 정도가 신청을 해주셨습니다. 지금 128분 중에 현재 이 시간에 지금 들어오신 분들은 지금 44분 정도고요. 그다음에 저희가 이제 이메일로 그 안내를 보내드렸을 때 이제 프로그램 설치상에 이제 문제가 있으셨던 분들이 한 10분 정도가 계셨고, 그중에 상당 분은 어제 이제 개발자가 직접 접촉을 해가지고 문제를 해결한 걸로 알고 있습니다. 개발자 접촉 전에 이제 대우건설의 진병무 박사님은 방법을 찾으셔가지고 해결을 하셨는데요. 아무튼 이제 또 추가적으로 문제가 있으신 분들도 저희 그 개발자하고 접촉을 하시면은 직접 해결이 될 것 같습니다. 먼저 제가 강의 시작 전에 이제 엑스 윈드에 대해서 잠깐 설명을 드리면은 좀 이따 김기두 교수님께서도 얘기를 하시겠지만 김기두 교수님은 저희 해상풍력 해양플랜트위원회 전임 위원장이십니다. 그래서 이제 그 거의 30년 이상을 이제 이 패키지를 이제 개발을 해 오셨고요. 육상 해상 풍력에 대해서 아니다 해상 풍력 고정식에 대해서 이제 산자부 연구 과제로 3년간 진행하셨고 지금 최근 3년간은 또 이제 부유식에 대해서 이제 연구 개발 모듈을 하고 있습니다. 주로 이제 김기두 교수님께서 개발하시고 제가 일부 이제 무슨 그 컴퓨테이셔널 미케닉스 파트에 대한 모듈을 제가 개발을 하는 작업이고요. 그다음에 고정식 구조물에 대해서도 이제 진작 완성은 됐었는데 이제 검증 작업을 제가 진행 중이라서 지금 기술 교육을 제가 계속 미루고 있다가 최근에 이제 그 제가 이제 논문을 쓰는 과정에서 제가 그 고정식 해상풍력 구조물에 대해서 아주 인텐시브하게 사용을 해서 이 정도면은 이제 고정식 해상풍력에 대해서는 통합하중 해석 프로그램으로 사용해도 무방이 없겠다고 판단이 돼서 이번에 이제 엑스피라스 IT 측과 해서 이 기술 교육 강좌를 구성하게 되었습니다. 정리하자면은 이제 고정식 해상 풍력은 일단은 작동이 되고 지금 문제가 거의 없습니다. 그래서 주로 이제 모노파일, 자켓, 트라이포드 사용하는 것들이 통합화중 해석이 다 진행이 되고요. 부유식 해상 풍력도 지금 어, 완성은 됐습니다. 하지만 지금 검증 절차를 제가 진행을 해야 되기 때문에 그 작업은 제가 그 기술 교육은 추후에 다시 시간을 잡아가지고 진행하도록 하겠습니다. 그래서 지금 오늘 강의를 한 내용은 제가 말씀드리겠지만은 그 유튜브에 지금 다 공지가 될 거고요. 또 유튜브는 지금 그 제가 제 연구진들하고 이제 커뮤니케이션을 위해서 제가 유튜브 채널을 따로 하나 팠습니다. 그래서 여기 쌤랩 TV로 해서 제가 한 모든 세미나는 여기에 다 업로드해서 저하고 같이 연구하신 분들이 이 데이터를 나중에 또 볼 수 있도록 제가 조치를 하고 있습니다. 그래서 오늘 세미나도 녹화를 뜰 거고 이 녹화본은 여기에 올려드리도록 하겠습니다. 그리고 이제 그 강의 전에 제가 그 X 윈도우를 사용해 가지고 실제로 지금 국제 논문에 발표를 해서 어, 지금 게재한 논문도 지금 이 채팅방에 올려놨습니다. 그래서 요거를 다운을 받으셔 가지고 실제 어떻게 사용했는지 한번 보시면은 이 강의 외에도 어떤 부가 자료로 꽤 유용할 것 같습니다. 여기 논문에서는 어떤 작업을 했냐면요. 통합하중 해석을 해가지고 여기 고정식 구조물을 지금 분석을 했고요. 이 구조물하고 기초를 따로따로 할 수도 있고 아니면 구조물하고 기초를 전체로 다 모델해서 지방까지 모델도 할 수 있습니다. 아까 말씀드린 대로 X윈드에서는 고정식도 할 수 있고 여기 V식도 할 수가 있습니다. 고정식은 검증 작업이 다 끝났고요. V식은 검증이 남겨지고 있습니다. 그래서 이 논문에서 했던 거는 여기 이 그림 6번을 보시면 되는데요. 이 기초가 없이 고정된 타입하고 그다음에 구조물하고 기초가 같이 부가된 타입하고 이 두 개를 모노파일하고 이 자켓에 대해서 전체 통합하중 해석으로 고동 분석을 했던 논문입니다. 자, 그러면은 저희 그 전임 위원장이시고 그다음에 개발자이신 김기두 교수님 말씀을 잠깐 듣도록 하겠습니다.
네, 안녕하세요. 전임 위원장인 김기두 교수입니다. 현재 위원장인 지강수 교수님의 열정으로 대한통합계 해상풍력회가 더욱 발전하고 있는 것 같습니다. 저희 엑스피나스 IT는 해상풍력 시스템 개발을 위해서 설립한 회사로 현재 산자부의 지원으로 엑스윈드를 개발하였으며 그리고 지속적인 연구 개발을 통해서 웹에서 작동하는 웹윈도도 개발을 하였습니다. 향후 사용자 편의성 및 경제성 있는 소프트웨어를 개발하여 국내의 해상풍력 사업에 기여를 하고자 합니다. 특히 오늘 강의는 미국 NREL에서 개발한 오픈파스트를 이용해서 하는데 이 오픈파스트는 이미 GL의 발전용 인정을 받은 검증된 소프트웨어입니다. 이 검증된 소프트웨어를 다시 저 연구단을 통해서 한 번 더 검증을 했고요. 그래서 이 X 오픈 파스트에 관해서 조금 있다가 닥터 파신이 자세한 설명을 하고자 합니다. 이상입니다. 그리고 많은 참고 문헌은 조금 전에 지금 채팅을 통해서 말했듯이 www.xpinas.com의 홈페이지 레퍼런스에 있습니다. 이 레퍼런스에 저 연구단에 관련된 많은 참고 문헌들이 있으니까 필요하시면 다운로드도 가능합니다. 이상입니다.
네, 감사합니다. 그다음에 저희 김 교수님께서 부가적인 내용을 말씀 안 하셨는데 지금 특히 이제 고정식 파트는 그 영국의 그 캐터펄트사, 그러니까 일종의 이제 그 인증 기관 같은 건데요. 그 캐터펄트사에서 이제 프로그램 검증을 별도로 진행을 해가지고 그 인증서도 지금 현재 취득한 상태입니다. 그리고 닥터 파신, can you
Yes,
talk?
sir. Yes, sir. Yes, sir. Did you hear
And we
me, sir?
can now. I'd like to hand over this education to you. Can you start the installation procedure again? I believe not everybody has successfully installed the Xwind program. So as you told me, so you can repeat the job so that people can follow.
Okay, maybe the first of the thing, maybe I need to introduce our website first and we can get through the download.
Yeah.
So
Please share the screen.
Okay, did you already saw my screens, right? So first of all, allow me to introduce our website, xfinat.com. So we have contain a lot of the information that Xwin embed into the AutoCAD, and the WebBrin program is the web service that allow you to use some kind of functionality to the web browser, such as the Chrome's or Firefox or Microsoft Edge. Yeah, also including the cloud computing that give much more speed than the personal computer. So inside our websites, right, they have some kind of reference you can access to there and download the presents or the update version of the tutorial manual of this demonstration. And by the way, on the first or the second page, they have some detail in the Korean language. That means it easily can be understood clearly. So let me turn to the homepage of our website. At the homepage, right, it has contained about the link that you can download the programs via to the GitHub. After you enter to that position, you will see that I already provide the Xwin application version of the 2.01s. So you can download it and extract the file into the storage folder. After you extract into the storage folder, example that I already have been extracted into the XC here. Please open up about some AutoCAD software and navigate to the new to create it, a new drawing sheet. Please type on the net load at the command line and press enter. The program is really request to browse the DLL. That means you can access to the XCs folder. Scroll it down. You can see it's on the XCs plugin.dll. Open that file, and they already request is this load or not. That means you need to choose always be loaded. By the way, type on the X-Wing. That's it. You can see that on the top of screen that the X-Wing ribbon menu will be rotated. Okay, let's get back into our demonstration then. So in this demonstration, the OC4 wind turbine jacket is model anchored on the seabed with a fixed boundary condition. The total range of the jacket structure is allowed 70.15 meter and penetrate into the water depth, allow 50 meter, and extension allow 20.15 meter. This structure will be responding to the wet kinematic with the water depth 50 meter, water density 1025 kilogram per cubic meter, and significant wave height allow 8 meter. Wave period is 10 seconds, also including the marine growth, starting from at elevation -40 to the elevation -2 meter with the density 1100 kilogram per cubic meter, and the thickness is 0.1 meter. So there are 2 types of the material property and the 6 types of the circular tube section as shown in the table and classified by the bracing, lower leg, middle leg, top leg, pie head, and pie. The TAPSIM program will be used to utilize to generate the wind turbulent data at speed allowed 12 meters per second and apply on the tower and the bridge. This kind of data will be published by the National Renewable Energy or the NREL. The objective in this demonstration would like to obtain about the maximum load and the stress in the time history for the further analysis, such as some analysis FLS or the ULS. So I think let's go to see at the first looking of the X-Wing program by running the AutoCAD software. So I have the 2 versions of the AutoCAD. Maybe I will use one version to be starting with you first. Navigate to the start drawing. Maybe the new version, they didn't use the start drawing anymore. They use just a new button and click that to create a new drawing sheet. After you create the new drawing sheet, our 9 ribbon menu will be shown up, included XCs preprocess, mooring to, X open fast, X Nemo, X anchor, lab ditch, calculate, XCs preprocess, and help. Normally, XCs preprocess is used to the general purpose of the main solution control, such as controlling about the file system, controlling about the mesh unit, choose the type of the solution. We have many kinds of the solution from the analysis, like a linear static, nonlinear, natural frequency, linear buckling, or many more. In this demonstration, we will use on the open fast analysis and allow the user to be assigned about the material property section or group the section into the line of the element, assign the boundary. So assign on the load also and include it to control about the round belt of the CAD and 3D rendering shaft. In the X open fast, normally it is constructed by, normally it is based on the NREL procedure, is be able to be analysis on the fixed or the floating wind turbine offshore structure, and it has been enhanced the performance of the pre and post process by Xfinance IT. such as the graph plotter that we have enchanted and the animation, even though including on the FLS and UAS analysis of it. Okay, let's get back to the 2023 version. I think this is better. I will leave it this one to be another work. So before you starting to creating the model, you need to be ensure about the unit systems in the AutoCAD. By type the unit, I will go it very slow. Add the command. After you type it, please enter. You can see that initially they set on the unit inside the AutoCAD as the inch. That will have the problem when we try to create the model that I provide in the tutorial, because that is belong to the SI unit and meter. So you need to change the unit to scale in insert content to be the meter. Press OK to be confirmed that. So finally, we already have it. That means this drawing sheet is considered on the meter unit. Let's talk about on the modeling. So we have the three kinds of the modeling method inside the tutorial. The first is the line 2. Normally, line 2 is a straightforward approach and for generating the line using the AutoCAD as provided in this demonstration. You can navigate to the home, select on the line. As you see that, they will request to specifics on the first point. After you input something on the first point, they will request to the second point of it. Or you can drag and drop it on the screen as you want. So to construct all of the jacket structure, we have allowed 112 lines to construct it. I already have provided in the appendix. That means
Dr. Pasin,
and
so
follow.
Dr. Pasin?
Yes, sir.
Sorry to break. Can you slow down the speed of your the lecture progress so that people,
Okay, sir. Yes, sir.
yeah, if you do so fast that I have difficulty.
Okay, so let me repeat one again about the line 2.
So especially when you navigate between different options, you should.
Yeah, you should navigate to the home. This is the first method to the modeling technique. This is a very simple method, but this is much more difficult in this time to be complete in whole structure. You can navigate to the home ribbon menu of the AutoCAD. Select on the line icon. As you see on the command line, they request you to specific on the first point of the coordinate. So you need to enter like some example. I enter for the first point is 666 and enter it. And they will AutoCAD will be request the second point to be drawing. That means you can approximate like 555, it doesn't matter. You can see that we already have the line occur here. But this whole structure, I mean, if you try to use this kind of the method, they have allowed 112 elements. So in the appendix A1, if you try to allow page number 70 on the update version, and the old version may be on allow 66, you can see that I already provide the first coordinate at second point of coordinate also. So you need to fill up everything to be make a drawing completed. That means have 112 line to be complete on the jacket structure. This method is consuming a lot of time, so I do not recommend on in this demonstration. I have another like a second method. The second method is just like we use the AutoCAD command. to construct about the specific model by using the AutoCAD. So you can drive to Appendix A2. Okay, you can see that they have contained around 3 plates. 1, 2, 3. Easily, just copy in whole of it for the first page first. By Control C, and then go to the AutoCAD. You can see it's on the command, and press by Control V. Now the jacket model is starting to make automatically. After you finish it, just press ESC to be cancel or escape. So you need to fill it up with the page number 2 and page number 3. This is a page number 2 for the command to make it drawing. See that? Now this is almost completed. Let's go to page number 3. So finally, we already got the completed one on the jacket model. By the way, additional method is the third method. We use the jacket template, but please do not follow me, because if you follow me in these terms, you already have the model, and we would like to go in the very classic method, not just like the advanced one, but I would like to show it to you. This is more simple and easily. So we navigate to the axis preprocessed ribbon. Please do not follow. Can you see it's on the file category? Extend the file category. We have the template extended. It will include the jacket template, monopile, tripod, and the
Dr. Pashin, can you hold a little bit? So I'd like to explain them, what the current stage is.
Okay.
지금 저기 닥터 파시는요, 일반 이제 소프트웨어에서 사용하는 방식과 같이 이제 그 메쉬를 만드는 법을 얘기를 했습니다. 그래서 절점을 이제 오토캐드에서 이렇게 생성을 하고요. 그다음에 이제 오토캐드에서 라인 커맨드를 해가지고 이렇게 그리면서 쭉 찍을 수도 있고, 아니면은 뭐 절점 미리 정해진 점을 이용해가지고 이렇게 메쉬를 만들 수도 있고, 이제 그런 방식으로 해서 메쉬 만드는 법을 설명을 했고요. 그다음에 이제 여기 오토캐드 상단에 보시면 저기 Gmesh라고 있어요. 그 Gmesh를 사용해서 외부에서 메쉬를 만들어 가지고 그 데이터를 그대로 임포트 할 수도 있습니다. 그래서 그 2가지 방법을 다 얘기했고, 그 2개 다 그 얘기를 2개 다 해도 사용할 수 있는데 시간이 너무 오래 걸리니까 지금 저기 X 윈드에서는 이제 많이 사용되는 구조물 타입인 그 자켓하고, 그다음에 뭐 모노파일, 그다음에 그 트라이포드네요. 여기는 미리 이제 그 특성을 반영해서 일종의 이제 BIM으로 얘기하면은 그 파라메타 모델 형식으로 그 템플릿을 만들어 놨어요. 지금은 이제 그 얘기를 할 겁니다. Sorry, go ahead now.
Okay, sir. But please do not follow in this method. I do recommend it because of everything will be inserted to the frame section and X frame automatically. Okay, let's go to the very simple way. To build on the jacket, right, on the manual, lie on the detail. If you drive to on the manual, page 10 for the new version of it. 01 is should be 6. You can see that I already provide about the information to make the jacket by using the template. So if you follow this kind of the table, you can build the jacket easily by put the number story equal to the number 11. 11. Bed width is 12, offset is a 2. Then should be fill up all the table on the story number 1. Let me fill up everything and I will show you.
그러니까 여기 이제 자켓 그 단 개수를 그 설정을 하고요. 그 다음에 이제 바닥 그 풋프린트라고 하죠. 풋프린트 폭을 설정한 다음에 이제 각 층별로 이제 사이즈가 얼마큼 되는가 이제 입력하는 겁니다.
Okay, let's make a straight line on the floor. Number 1, 2, 3, and then 10 and 11. So we create the horizontal line to the floor number 4 and cross number 6, 7, 8, and 9. So now we already complete on the jacket model by using the template, and can pass to the mesh by using the count number 1 and create it. So finally, we already have it on the jacket modeling and automatically inserts the data to the geometry side. That means that the list of the detail of the geometry section will be initialized, but you can modify later on. Okay, this is a third method, but by the way, we need to go on the classic one. I will close this one and use on the 2023 instead of it. So I think everyone already complete on the model. To generate the mesh, we need to select entire of the model that we would like to generate the mesh by using the Gmesh. Navigate to the axis preprocessed. Move it to the mesh category. As you see on the first icon that they show on the Gmesh, GMSH, click for that. Can see that the model that you model in the AutoCAD will be loaded into the Gmesh software. On the left panel, they have the data tree to be controlled about the mesh size and define many things more. Please extend about the mesh. Extend define and extend time finite. Now we get to the curve. They require to put the number of the point. I recommend to nowadays put just only 2 points of it because we prefer to generate just only 1 line per 1 element. Group it all on the screen by holding the control and click your left mouse or your left mouse and release it. You can see it's on the top of the screen. They show that press E to be end select. Just press E on your keyboard. They request to save the geometry into the file. Just process as is. Finally, everything is already finished. You can see it's on the top of the screen once again. They say that Q to be abort. Just press Q to be abort the window. To generating the mesh, navigate to the line 1D. Click here. As you see on the bottom screen, they show that done meshing 1D. Okay, let's go to double checks by navigate to the 2 on the top of the screen. Go to the option. They have the mesh. See on the element label. That means the number of the mesh is generated completely. Or we can check by the node label also. Okay, if everything has been confirmed, close it. Navigate to the file, save match. So we need to turn off the program by navigate to the files once again, quit it, or you can close directly. So we need to open the mesh that we have been generated. Navigate to the axis pre-processed ribbon. And you can see it's on the mat category. They mentioned about our icon name, open mesh. Click that. The model has been drawn completely with 64 nodes and 112 lines.
Okay, let me summarize up to this point.
Yes, sir.
So you built the computational mesh now. So you have space for the finite element meshes at this point.
Yes, sir.
Yeah. 지금 여기까지 정리 드리면요. 아까 이제 뭐 절점하고 그 라인은 그 일종의 이제 그 지오메트리칼로 그러니까 기하학적인 연결 그림 같은 거고요. 이제 그 그림에다 따라 가지고 실제로 이제 유한 요소를 할당하는 거는 지금 GMS에서 지금 그 작업이 이루어졌습니다. 그래서 여기까지 지금 설명한 거 되겠습니다. Okay, please go ahead.
So we can close the mat static. And navigate to the basic condition category. Please see on the unit. Please ensure that everything has the SI unit already. But by the way, that initial settings already, that means no need to be choose anything. Navigate to the solution. You can see it's on the analysis option. Please change the analysis option to be the open path analysis. So we can press the OK to be confirmed about the saving data or close it. It doesn't matter because everything is automatically saved. So in this jacket structure, they have two kinds of the material. The first, we need to define the material by navigate to the material property and click to the icon of the name of the material. In the isotopic, we already initialize for the first value of the material. You can additional one more. You can see it's on the top of the screen. They have the plus symbol. Click to add one more of the material property. You can fill up here or in the table, it doesn't matter. Example that I will fill or change some value in the table. That's why I just insert the data to here. Change the isotopic name as you prefer it. I will change to just read the number 2. With their second density has been changed to the 3339.12 as referred to the tutorial. On page 17. because that is still, by the way, that young modular elastic is not be changed, and Poisson ratio is always be 0.3. Okay, I assume that everyone have been finished. Just cross or press the OK, it doesn't matter. The next, we will go to assign some section property. Navigate to the frame section at the geometric property category. Click on the frame section. You can see that we have the many type of the section property. Can be choose close, offshore, general section, or the section designer. In this jacket, always use the circular tube. That means go to the cross section. Navigate to the circular tube. Click it. The first of thing they will request to input the names. So we can use any kind of name that we want. The first section, I will follow the table that I have been using in this tutorial. You can see it's on the table here. That the name is, first name is the bracing, second is the lower leg, third is the middle leg, fourth top leg, fifth is the pie head, sixth is the pie. I will change the name to the bracing. Press OK to be confirmed about the name of the section. And here you are. They allow you to put the radius. It should be 0.4 for the first one, and the thickness is a 0.02 meter. After you input until this step, on the top of on the middle of the screen, not top one, you can see it's on the show preview. After we click on the show preview, then we show on the real section shape. And even though hide it. Below that, they have the dimension and section property. You can double check. Click on the section property. You can double check it about the property of this kind of section, like area, torsional constraint, moment, polar moment first and second moment of inertia. To add one more circular tube, where linear locate on the show preview and hide preview, it has some plus symbol. Click there. Choose on the cross sections once again. Navigate to the circular tube. After you click it, they require to input the name of section. Now I will input the lower leg. Press it. Now the second is coming. The lower leg is radius is about 0.6 with the 0.05 meter thickness. So do this everything until it is complete on the 6th type of the circular tube. I will do on number 3, name as the middle leg. This is a 0.6 for the radius and the 0.35 for the thickness. And next is there should be top. With the radius 0.6 to the 0.04 thickness. And for the fifth one, it's the same thing, but if you are mistakes by the names, like I do here, you can see that I can modify, you can see that, you can see on the icon like a pencil, very near locate on the category. Click here to be modified names, like pie head. The name has been modified. With the radius equal to the 1.014, and the thickness is a 0.491. Okay, but in this state, on the pi head, we need to change to the material type, because initially we will set on the isotopic equal to 1, but this pi head refer to the isotopic 2. Next is this last one for the pi. With the isotopic 1, 0.041, and the 0.06 thickness. So everything now have been complete to define on the geometry property. You can close it and terminate this window. Okay. I will navigate to the X frames that we can assign the property to the line of the modeling that we have been done as before. So please navigate to the X frames at the category of the element library. You can see that on the X frame. So I will start assign from the bottom to the top. That means X frame 1 had been defined as the pi first. Choose the cross section to be the pi. Okay, then we need to rotate the model a bit to make it more clear. By we go to the top of the screen, working screen of the AutoCAD, and we can change the southwest isometric. This is more clearly for me, but depending on you guys or so. So on the left-hand side of it, can see it's on the qubit that can be rotated about the model. I will change to the front instead of it. Just zoom up to the model at the pi. You can see on the yellow box that is referred to the node. To group up the pi, you can use the AutoCAD tool by drag from the right to the left. Select just read the last bottom line. If I rotate a bit, you can see that they have 4 lines has been selected. That's why I rotate to the front. This is more easy to working on it. Go back to the apply of the X frame window. You see it's on the line element, line in the middle screen, on the tops of the table. They have the plus symbol. We need to add the data here by click on the plus symbol. So now line number 1 until 4 has been added into the table. Let's go to create the X frame number 2. On the top of the assigned X frames, we have the plus symbol or something. Click that to create a new one. You can change the name whatever you want, but I don't want to change it. By the way, I just use the X frame instead of it. Press OK. They will request to assign another. Choose the section to be the pi head. Let's turn back to be the front wheel. The pi head location is the next from the pi. It's the same thing that we select on the 4 element. Add it into the table list. Okay, now next we move to the X frame number 3. Choose on the top leg. Sorry, should be on the lower leg. Turn back to the front wheel and zoom it up. You can choose this kind of the 2 leg and more here on the top of it. Rotate a little bit. Choose on the 1, 2, 3 more, 4 more. That's mean the total in this lower leg have include around 16 element or 16 line. Add it into the table list. Okay, let me shift it, move up. For the middle leg, additional for the X frames, choose on the middle leg of the cross section. This middle leg we need to shoot by ourselves because we cannot use the front wheel. If we choose use the front wheel, it will be select on the breathing. That means we need to select 1, 2, 3, 4, up. Another story. And 4 more, almost near the top. Actually, if you see it's on the tutorial, I have been provided a location that you can select easily here. By its location to be point to the X frames of the bracing lower leg, middle leg, and top legs or so. Add it into the table list. We move to the X frame number 5. That's mean shoot on the top leg. We rotate to the front once again. You can see that we are remaining on the leg, accessory on the top. Select it. That means they will shoot 4. Add it into the table list. So finally, we go to the last one of the X frame. Choose on the bracing. That means they already selected for me because they initialized for the first one. Choose on the bracing. I use the front wheel to select in hole. Rotate it by using the light. Choose once again. Okay, that means hole of the bracing has been chosen. Add it into the table list. Up until now, if everything you has been done successfully and has been complete 100% without the problem, you can close the window. Go to the rendering window forms, that category inside the rendering. You can see it's on the line. Navigate to that. Click it to be rendered about the 3D shape. If shapes have been corrected, it will be rendered like this kind on the screen. On the AutoCAD, they provide some kind of the option to see the view very clear. left-hand side of the screen, they have the 2D wireframe here that is belong to the AutoCAD. You can change to any kind of the display, like a realistic. That just mean much more clearly to see it. Or the shade of the gray. Okay, let's go back to the 2D wireframe and turn off by clicks once again at the line. So it's almost final in the XC3 process. The last one is the boundary condition that we need to enter for the fixed offshore structure. Let's back to the light for me. Navigate to the boundary condition category. Can you see it's on the top of the icon? They refer to the restraint. Click that window up. We need to lock the translation and rotation because this is the fixed offshore by turn on U constraint to be locked V, W, X, Y, Z. Zoom up to the bottom of the structure. You can see it's on the node with the yellow color, rectangular yellow color. That is the node. You can group it. Choose the line, it doesn't matter because they will select to choose just three for the node. Add it up or do the same thing to be here to the table list. After you add it, they will show about the cone symbol. That means two cones refer to the rotation. One cone refer to the translation. Okay, finally, everything has been complete on the XC3 process. We can move to the X open fast. Let me just return to the original wheel. Now we get to the X open fast ribbon menu. After you click it, they have a lot of the icon in the front of it. You can see it's on the pre-process first. Normally, the pre-process of the OpenFast will be controlled by the primary control. The primary control has used to be control the main solution and control about the file system that used inside the couple analysis. So the first other thing we need to define on the primary control. They will separate on the right-hand side and the left-hand side. Right-hand side is used to insert the data and choose it, some kind of the parameter. Left-hand side is some kind of the category in this icon. Like on the primary control, we have allowed 5 categories to be filled up. So the first, you go to the simulation control. You need to turn on the echo input data. That means it will within the results. I recommend to be choose the earlier failure as the fatal. Because of, if you use the warning, they didn't break the program and they didn't warning any kind of the message much. The fatal is much more better to be break the program and show the error when you try to analyze it. Total running time, I recommend nowadays just 60 seconds is enough. And the time step for the analysis on the wind turbine. Now just 0.01. Choose in the linear interpolation order as the quadratic. Number of the correction iteration times Jacobian you can leave as it is. So if you cannot follow, you can go to our manual that is a line on the detail. Line in here, we go to the primary control. That's what we need to choose it. Next, feature switch and flag. This is the main control that how many modules you prefer to use it. Compute structural dynamic. We always use the elastodie because elastodie always control about the tower and the main controlling about the turbines and nacelles also. We need to turn on to and choose it on the elastodie. Normally that already initial set for the elastodie. Second is the inflow wind velocity. So we use the turbulence data from the top sim. Please choose the inflow wind. Aerodynamic. This is the 15 version. Yeah, just a single that we need to turn on it. And servo die should be chosen. That is the electrical driving system or gearbox data. On the compute hydrodynamic load, please choose on the hydrodynamic because we need to consider about the web kinematic. We have the substructure, right? The module that we use it need to be request on the subdie. So the modeling system is not required and the ice loads also because of the modeling itself connect to the floating structure and the ice load. We didn't consider in this demonstration.
Can I break at this moment?
Yes, sir.
To summarize what you say. 질문이 이제 개인적으로 저한테 계속 몇 개가 왔었는데요. 답변은 지금 전체 수신으로 제가 답변을 해가지고 지금 채팅에 이렇게 많이 뜬 거고요. 또 혹시 뭐 질문 있으시면은 그냥 수신자 모두로 해가지고 질문 주시면은 그 모두가 그 질문 내용하고 제 답변을 다 보실 수가 있겠습니다. 그다음에 질문 주신 거를 지금에 맞춰가지고 여기 현재 하고 있는 거 설명을 드리면은요. 지금 현재 하는 게 통합하중 해석이기 때문에 그 터빈의 거동하고 윈드의 거동이 들어가는 게 필수적입니다. 그래서 위에 이제 일라스토 다인이 있는데 일라스토 다인은 그 타워 모션하고 위에 이제 터빈 모션이 같이 들어가는 거고요. 그 오픈 파스트에서 그 모듈을 이용해서 직접 계산하는 거고 그 다음에 두 번째는 인플로우 윈드는 이제 바람 타입입니다. 그래서 여기 이제 그 바람 타입을 선택하는 거는 지금 닥터 파신이 설명하는 데서 빠졌는데요. 이거는 이제 통합하중 해석할 때 그 DLC 콤비네이션 테이블이 따로 있습니다. 그래서 거기서 보고 이제 판단을 해야 되는 거고요. 여러 이제 통합하중 모듈을 그 지금 현재 이 개발한 X 윈드에서는 아예 통합하중 세트를 그 로드 케이스를 뭐 100개고 200개고 한꺼번에 돌릴 수도 있는데 그 파트는 지금 오늘 설명을 안 드렸고요. 여기 옵션에 지금 가지고 있고 그 다음에 이제 에어로다인 로드는 이것도 역시 에어로다이나믹 로드 그 모듈 계산하는 거고 그 다음에 이거 서버다인은 이제 그 저기 아까 말씀드린 그 통합하중 그 DLC에 따라 가지고 터빈을 제어하는 이제 그 방식에 따라 가지고 여기가 있는 거고요. 그다음에 하이드로다인은 여기 이제 오션의 비헤이버입니다. 고정식은 모리슨 이퀘이션으로 되어 있고요. 그게 이제 모션의 하중을 여기 그 선 형태로 된 그러니까 1D로 된 이 요소에다가 분포 하중으로 이제 가력이 돼서 실제로 이제 고정식 구조물에 변이가 생길 때마다 하중이 실시간으로 풀어져서 커플이 되어 있는 형태라고 보시면 되겠습니다. Okay, please go ahead.
Okay, next we navigate to the output control on the left-hand side of the panel. So the output control is required to be seen the results And for the time step of the start tabular output is set as the 0.05, but you can leave as it is. It doesn't matter for the initial line fit. And the time begin tabular is equal to 0. But I do recommend to print the results on the text file. Okay, that means you can choose on the text file and should be included tab delim as on. I recommend to be, should be, because if we didn't turn on for that, the results is very unformat. This is not good to be seen on the Excels or something else. Okay, the linearization is not required in this step. We go back to the visualization control. The visualization control or the VDK itself is used to make the animation. To use the animation, we need to turn on it by choose the animation at the VDK visualization data output. After you choose it, they require more like what is the data you would like to be print for the animation. In this step, I recommend to be shoot on the surface. Okay, let's go to see add a look at the frame rate for the VTK output. This is a very important thing because of that is a frame rate per second. So if you include a lot of it, like 100 or 1,000, so it will be consume a lot of the space. Actually, like this kind of the analysis nowadays, we running around 60 seconds, and with the time step is the 0.01. With the VTK file in the VK, with the video animation, that's been consumed around 3 GB already. So just leave at the 15 as is enough.
By the way, what's the VTK stand for?
It's just animation, visualization control. Okay, just turn off it. So after normally when you complete on the features with and flex, right? The ribbon that required to input inside the OpenFast is will be coming. That means you need to fill up everything on the structural control, aerodynamic and flow, hydrodynamic control, operational substructure control. So I will show you one by one. So let's go to the next on the structural control. Normally, as I explained it, everything is almost being set for the 5 megawatt NIEL turbines already. But that setting is based on the monopile, not the jacket structure. Some data should be required to be adopted and adjusted. So we can go to the simulation control of the structural control. You can see that integration method. They have the three type of it. We need to choose the Adam Bradford mount fourth order. And just leave the indication time step as the default. That means it will be follow the time step on the primary control.
Can I intervene a little bit here?
Yes, sir.
I'd like to switch the screen share to mine. For example, 여기서 보시면은 전체 이제 구조가 나와 있는데요. 제 논문에서 이제 했던 문제를 다루고 있는데 여기 구조를 보시면은 이제 좀 복잡성을 좀 아실 수가 있는데 옆에 이제 타워가 있고요. 그다음에 터빈, 블레이드 등이 있고 그다음에 이제 구조물이 있고 또 옆에는 이제 오션이 있고 그다음에 이제 지반 물성치가 따로 있고 파일도 이렇게 있습니다. 그래서 요 각각이 이제 개별적인 모듈 형태로 구성이 돼 있고 이 모듈과 모듈 사이의 정보가 이제 왔다 갔다 하면서 되는 거거든요. 근데 만약에 이제 모듈과 모듈이 전체적으로 다 한 세트로 구성이 되는 경우는 이제 프로블럼 사이즈가 이제 너무 커지게 되고 한 번에 풀기가 이제 굉장히 어렵습니다. 그래서 이제 지금 전 세계적으로 이런 멀티 피직스 문제는 대부분 이제 모듈 단위로 분리해서 지금 하는 것이 일반적이고요. 여기 이제 화살표로 뭐 검정 화살표, 그다음에 빨간 화살표 등으로 이 표기된 부분이 이제 모듈 간의 데이터가 왔다 갔다 하는 방식인데 요 데이터 왔다 갔다 하는 방식이 완전히 이제 임플리시스로 되는 건 아니고요. 일종의 이제 explicit인데, 그러니까 좀 전에 말씀하신 그 적분 방식이라는 거가 결국은 데이터 타임 도메인에서 데이터가 왔다 갔다 하는 방식을 4차의 런지쿠따로 하고 있다. 그런 뜻으로 생각하시면 되겠습니다. Yes, sorry. Please go back to your screen.
Hey, yes, sir. So after completed, we navigate to the environment control, but I think we don't need to modify anything to the environment control because they just require the gravitational. But this is a raw, cannot be changed. So just next go to the degree of freedom that I already have mentioned it because everything has been set. You need to turn on for the bread DOF because we consider on the bread, nacelle and tower, but should be turned off on the rotor teeter. That's one used for the two bed. After turn on everything, should be include the turn on the platform DOF also because include the 6 degree of freedom on the platform. That's mean on the substructure itself. That means you don't need to touch anything to be on the degree of freedom except you change to be the fourth thing that should be considered. To the initial condition, they have allowed the control about the bed pitch angle and some kind of the angle to be on the bed itself and on the tower. The rotor speed we set for the 12.1. That is great enough for the operational speed. That means it's not required to be changed. But by the way, as I mentioned it before, this kind of the set thing is made for the monopile, not for the jacket. That means on the platform, we need to modify it. But on the top of the tower, everything is not required. So you can see it's on the platform that vertical height should be adjusted is to the minus 0.227, as I remember, maybe. Yeah, that is correct. 0.2 for the platform vertical height direction. So let's navigate to, again, next on the turbine configuration. We need to set everything on the 3 bed. That means the distance on the rotor is correct already, 63. And about the cone pitch, this is a minus 2.5. Yeah, everything is almost correct yet because of we already initialized for the NREL 5 megawatt. But the tower itself has been changed. Because of the size for the jacket, it will be higher than the monopile. That means should be adjusted to 88.15 for the tower height above on the ground. And also same thing with tower height base above on the ground. It should be 20.15 meter. On the platforms, downwind, we can set add a zero here, that is correct. And vertical distance from the ground, it should be 18.15. And vertical distance from the ground platform difference also is 18.15. That is referred to the point of the center of the mass. So you would like to know about the bed pitch angles, right? Normally the bed pitch angle is just like the angle that bread acting on the nacelle. If you would like to see it in more detail, I recommend it. Let me go to the here. I think this is much more clear for the pictures of the bread pitch angle. You can see that the bread pitch angle is just like when the bread is acting to the rotor or the nacelle itself. This is some kind of the angle that bread is bent. So this is required to just like to the industrial company that produce on the bread to be pushed. Okay, if everything is clear, I will continue to the mass and heat shear. Normally, mass and heat shear has been used to be input by the user, just like the hub mass or the nacelle mass. That's mean the nacelle itself should be contained about the gearbox or other thing else. But by the way, this is the NIL 5 megawatt. Everything is already fitted, except the platform should be changed because of we didn't set for the jacket. That's mean platform mass. It should be 666 ton should be input belong to here. And about the platform initial load follow teach, if you follow the manual, that should be put in the 6.002 XX E part 06. It's the same thing with the platform initial for the pit teach to XX E power 6. Now, finally, we can input the data for the integer for the yaw teach 1.0229x e power 7. So the math has been conducted completely. Let's go to the choose on the bread type of it. We already integrate some kind of the certificate test from the NIL. That means you can choose the type of the bread by using the AOC bread, AWT27, SWRT bread, UAEVI also, or the BUP baseline. That is the name of the bread. But that is very small. AOC maybe just 1.5 megawatt, as I remember that. But in this demonstration, I will use just NIL 5 megawatt bread. That means you can choose on the NIL 5 megawatt bread here. After you choose it, every data layer, some kind of the stiffness coefficients of the bread, it will be inserted automatically. So the rotor theta is not required because this is true bed. And diving 10, we can leave as is here, just like the control about the gearbox efficiency. Tower, we have a lot of the type of the tower related with the certificate tested. So you can should be changed here to be the 17 node. So that's mean along of the tower, it will be divided to the 17 node or the 16th element. Choose the tower option to be the NREL 5 megawatt jacket. We have many more. You can see that we have the 5 megawatt for the monopile, tripod, even though for the floating structure. So the easiest way, just go to the jacket. So navigate to the outputs, control it. Maybe on the tutorial, they refer about the tower node table to be seen on the channel list. But this is not the main packet that I would like to show in this step. I will show you first. Maybe this term is make a bit confusing because related with the channel list itself. To be reduce your config. Normally, this kind of the channel list is provided by the NIL parameter. That means you can drive to the OpenFast document search on the open fast document on the Google, you can see that they refer the document in the online computation. Navigate to the user document. You can see that they have allow you to download the output list parameter.xls. You can download there. They have a lot of the, after you download it, they can see that they have a lot of the channel list resolved that we prefer to get it. But our target, we would like to get the tower base only. That means you need to put the channel list TWRBSFXT for the fourth. 3 of them is the fourth. Another 3 is for the moment. So if you return back to our tutorial, we already provide about the tower base here for the channel list. You can copy just only these 2 lines or whole of it, it doesn't matter. But in whole channel list of it, you need to connect with the break gate list. So that's why I do not recommend it nowadays, because it will make you confusing. I recommend you to copy just a tower base. That we prefer to get the results of the fourth from the turbine. Just copy it by using the Ctrl+C and then go to the output channel list in our window. You can see it's on the last one. They refer on the table of the output list. Click it to be shown it, and then Ctrl+V to be present. They will allow you to reveal about your pressing. That means they will replace about 2 lines. So after you press OK, they will insert to the table and cancel. But by the way, in the first line, we already initiate name of the data list is not required. You need to delete it. So that's mean the output will be referred to the tower base, force and moment in X, Y, Z direction. Okay, press OK to be confirmed once again, and OK to be turned off on the structural control. Now let's do on the aerodynamic control. So in aerodynamic control, we control about the systems or the theory and dealing with the aerodynamic force. That have many more on that theory, like a wake-induced force or something else. So the first thing, you can go to the general option. Change the type of the wake-induced model to the BEMT. That's it. And everything can be chosen. Set automatically like airfoil that we use the breast dose Leachman model, and the tower inference include the baseline potential flow theory. So next I will move to the environmental condition. So the environmental conditions already specific about the air density, like air viscosity, speed of the sounds, atmospheric pressure, vapor, the pressure or the fluid depth. That means you can leave it. Everything is already set it, except you would like to be changed. Now we get to the breath momentum theory. This one is already correct. For the skill wave correction, we need to use on the pit beater correction. Consider about the tip load model, hub load model, and the tangential induction in the BEMT calculation. So that means don't need to be touched on, even though on the Brudos Leachman unsteady model, that is some kind of theory used on the minima pitch valence and turn on the F lookup to be looked up at the file on the system. So next, we go to the airflow information. It's required some kind of the coefficients of the attack angle lift coefficient, drag angle, and pitch moment of the coefficient that has been set 1, 2, 3, that has been corrected, and CP mean coefficient that should be equal to 0. Yeah, that's correct. Choose the airfoil information data input as the NREL 5 megawatt. So normally they have a lot of the airfoil coordinate. Normally they're dealing with the airfoil coordinate. But if you have additional airfoil coordinate, you can use the airfoil browser file. And you can browse external file that you have it. By the way, if you don't have that kind of the file, you can use our one, just like the NREL 5 megawatt. That refers to just 5 megawatt. Or else, just shoot the NREL 5 megawatt. Then next we navigate to the loader and brake property. The brake property itself is always the same thing because we already provide for the NREL 5 megawatt. That means you can choose it without a problem. And please turn on about the use BICMs also. Okay, let's next go to the tower inference. It's specific about the tower data like a stiffness that used in the aerodynamic control. We can choose it for the NREL 5 megawatt jacket. And you can see that specific input with the elevation is coming. They refer about the drag force and turbulent intensity. Okay, please, okay to be confirmed. I think we don't need to dealing with anything on the output channel list in the aerodynamic control because we're not required to get any kind of the force from the aerodynamic. So we just cross it. Just navigate to the next icon is the inflow wind. The inflow wind is used to choose the type of the wind profile. We have a lot of the wind profile in here, just like lead from the steady wind, uniform wind, binary subsim. The binary subsim file and binary base style FF is almost identical. That is the turbulent intensity data. So as I mentioned in this demonstration, we use the turbulent wind data from the subsim. So we need to choose on the binary subsim FF. Next is will be require the upflow angle, and you can put as a 0 angle is fine for the initial list, and for the list of the coordinate initial direction is 90 for the C direction. That is enough to be analysis in this model. Choose the file of the subsim data. So this kind of the file of the subsim data will be published by the NREL, but we already impress and implement into our program. So that means you're not required to choose it. If you have additional file, you can click here and browse to another file that you prefer to analyze it. And by the way, in this kind of the program, we can analyze on the subsims also, but just later on the proposed. Okay, that's not mean, it's not me, have nothing to be dealing with the inflow wind much because output control have been already set to be seen on the wind velocity. Okay, next is a very important thing is the hydrodynamic control. Hydrodynamic control is used to control about the data or the parameter of the wet kinematic. We navigate to the environmental condition. Because of the water depth itself on the jacket is 50. You need to change here to be the 50 meter. Now we get to the web on the left-hand side of you. And the first initial state they set on the still water. We need to choose on the incident web kinematic model to be the John Schwab and Pearson-Smallwood spectrum theory. So they require, this is the kind of the random wave. They analyze it with the random wave total time step is T1630. And time step for the incidence wave is around 0.25. But we need to change the significant wave height to be the 8 meter and the peak spectrum period equal to the 10. That is correct. Low cutoff frequency is the 0. High cutoff frequency is the 500. So the direction is the 0 angle. This is enough. Length of the wave. This is 90. And we need to change on the random seed to be the text like a landlux. Okay, up until here, it is not required to input anything for the second order wave. That is for the fourthing, by the way. Current in this model is not required. We can move to the axial coefficients. The axial coefficients is referred to the mass and dynamic pressure coefficient, or which called drag coefficient. In this model, we consider about the mass and dynamic pressure coefficient, but we called is phi. We can keep it equal to 0. After you fill the information in the table list, you can press OK to be confirmed and put the number of the axial coefficient equal to the 1. Because of you have been defined, this table is one data. That's mean put here is number 1 also. Next is the number of member joint. Sorry. Normally, the member of the joint, we have two kinds of the method to make a modeling. We have the model and without the model. So in this step, we already start with the model. So everything from the model that we have been made at the beginning, it will be come through here. As I mentioned it, this jacket structure is contained around 64 points of the nodal joint. That's been already inserted automatically. If you go to see on the table, you can see that every coordinate that refer to the node point already insert with the axial coefficients ID. But axial coefficients ID in this step, you need to be considered with the period one to be mapping between the axial coefficient ID and the member of the joint. So all of the structure or entire of the structure, we used to use just only one axial coefficients ID or just only number 1. That's why everything is set equal to the 1. Joint overlap maybe no need to be referred in this step. So we go to the member of the cross section. This is not required also because of we define at the beginning. Every cross section that we define inside the frame section will be inserted through here. The total of the cross section is equal to 6 with the diameter and thickness. So we can press OK to be confirmed without a problem. Hydrodynamic coefficient. In the hydrodynamic coefficient, we control about the drag force and some kind of the pressure, drag and mass coefficients. We will use on the simple hydrodynamic coefficient. Everything should be equal to the 1. That's mean you can put here equal to the 1. Up until you filling this step completely, we can go to the member. Member also is not required to input it. Because of we have been complete on the model, the member itself is referred to the element. If you see on the table member list, everything has been filled up. Connectivity, met site, and hydrodynamic coefficient. Because of nowadays, we use the simple hydrodynamic coefficient on the previous step. In this table, That's mean just put number 1 on the hydrodynamic coefficient ID. If you use another coefficient ID, you need to change to the number 2 or number 3 on here. Let's go to next on the field member. The field member is used to fill the water inside the circular tube inside the model normally. In this stage, right, you need to navigate to the axis preprocess first because we need to use the number of elements to fill it up everything. Navigate to the axis preprocess. On the label, we can use and click on the element to be let the program show the element label. If you follow the manual, I have been marked it. Where is the location that we need to fill with the water? That means it belongs to the leg of the structure. The bracing is not be filled. Okay, so you need to construct and lead the number from here. That means you can see that we need to fill number 1, 2, 3, 4, 5, 6, 7, 8, right? But by the way, if you use the same method of the me, you can follow by this number that I referred to the manual. Okay, sir, sure. Okay, so the number of the field group, it should be equal to the 1, and that means the number of lead is equal to the 32. Well, number list is the 1, 2, 3, 4, 5, and follow the manual 6, right? 7, 8, 83, 84, 87. Let me show it. 88, 91, 92, 95, 96, 97, 90. Okay, with the height equal to 0 and density is 1,100. So after we have been completed, we can press the OK, and please refer to that. We already filled the number equal to the 1. Please input the number 1 here. Next, navigate to the marine growth that we mentioned as before. We have to count off the marine growth starting from the elevation -2 to the -40 with the thickness. With the thickness, 0.1 thickness for both of it. And mass density is 1,100. Okay. That's it for the marine goal. And we no need to dealing with the member joint or the joint of the output data, or even though on the output list. But if you prefer to see it on the web elevation, you can copy the output list from our manual, like I have provided on almost on the last page here. You can see that this is the web elevation. If we prefer to see it on the results and the hydrodynamic coefficient, hydrodynamic force, if you copy this kind of the channel results of the output list to the table, they will print the result here, but I didn't copy it. So let's navigate back to the X open fast ribbon menu, and it's a almost final one. This is the operational control. We control about the gearbox and electrical systems on it. So in the simulation control of the operational, please turn on the echo input data. Navigate to the pitch control choose on the bread style DLL, and everything is already filled up about the data of the pitch maneuver for the 5 megawatt. Go to the general and talks control that. Everything has been fitted, no need to be changed. High-speed shaft yield control may be not required in this model. Bed interface is required for the element dynamic library from the open facet. That means has been set everything. So it's not required anything to input it. The final one is the substructure control. The substructure control in the first of the simulation control categories, right? We need to change the integration method to be the Adam Bedford modified fourth order. So we are to the final element method. We use the thermochemical beam theory and then subdivide number per element. I recommend equal to the 1 if you prefer to see on the local force inside our program. Use CB reduction. Number of internal mode of the restraint equal to the X and 1% of the damping. Guyan damping, just user specific. With the 6x6 method, insert to the table at the point column 3 and row 3. By the value 1.0661 e power 6. Okay, press E to be confirmed. So we no need to dealing with the structural joint because of everything that we have the model has been inserted through here. Okay, bed reaction joint is also same thing. One has been referred to be the locks. That's mean everything you define from the beginning in the axis preprocess automatically insert to be here. No need to check it. Interface joint. This is very important to be declared about the locations of the point that exchange the motion between the substructure and the turbine. So the number of the interface point in this model, if you rotate a bit onto the to the top and go to see on the node travel itself, we need to include the number starting from the 13 to be the 20. This kind of it should be inserted to be exchange the data of the amount of the motion. So that means the number of the interface point equal to the egg. I will input the egg 1.
Hold on. It's you've chosen one additional element to release the brace out.
I didn't choose that. Just aside now. But because of
Look at the inclined one.
Sorry, sir.
Yeah.
Because of other captor, maybe I will choose the very clear one. Actually, it's not the number element, sir. It's the node between that element. Maybe that is a 4. This is 4 elements, right? Refer to be the egg point of it, starting from the number 13 to be the 20. The joint ID starting from the 13 and should be locked everything equal to the 1, 14, 1, 15. Zero is the release, 1 is this locked. We need to exchange the motion to the locks, the 1, 20. Now that's it. Everything has been complete for the exchange the motions among of the turbine and the tower and substructure also. So we drive to the member. Already everything has been included because member lists from the connectivity of the model. This means no need to be declared and modified. Section properties also same thing. We define at the beginning. For the young modulus, shear modulus, mass density, diameter, thickness has been integrated for here. We not need to request to be filled up on the cable, rigid link, additional, or anything else more. Yeah, everything I can say that finish it. We can go to the calculated. After you click to calculate it, they request you to be save a model. Please create one model, one folder. Type anything like OC 4, 5 megawatt jacket. I will just use number 1 because it will be overlap my work, and enter to that folder. Save the mode by any name. IOC4 jacket. Okay, now the program is running. So it will take around 10 minutes to 15 minutes, depending on the computer, by the way, or longer than that, depending on the situation and time step. So to make it short, I will close and terminate this kind of the
By the way,
solution.
have you loaded the calculation now?
Yes, I have it, sir. I will show
So
it.
now the calculation is running now, right?
By the way, I already terminated. I will show the completed one because of if we waited
Okay.
15 or 20 minutes. So I have the completed one to be complete on the analysis. So we just close it, refresh the data, open the Actually, this model I have been complete by following our tutorial. If you fill up everything, same as the tutorial. First, you can go to X OpenFast post-process. You can see it's on the graph plotter on the icon at the ribbon. Choose the graph plotter after calculation has been completed. The result will be coming for the wind velocity is the result of the wind. It's just like wind velocity, as I remember, meters per second. So you can choose and plot belong to here. Okay, that is the graph plot. Total time step is 60 seconds. We need to be created first. The target we need to be seen on the results of the tower bed. That's mean TWR, BS, FXT until the moment itself. Choose it. So this is our target for the tower bed, force and moment results. And we are able to be compare the results and export it by choose on the overlay channel in the single plot on the top of the screen. Shoot on the tower base once again. And moment, I choose on the 6 force and moment added. 6 results has been shown and compared in the single graph. On the top of the screen on the right hand side, we have the wheel data. Can go that. You can see it's on the top of the screen, they are allowed to export in the Excel format. If you prefer to see the results and export the results, just read the tower bed on X direction. You can export now by click on the Excel form. But I prefer to export in whole. That means go to the overlay channel data. Just let the program compact a bit. This is a table. Okay, we can export to the Excel by click on the Excel icon and save it. We'll save, add the same thing. Maybe resolve that one. Okay, after you save it, you need to drive to the folder that you have been saved. Now has been completed to be exported, and you can find the maximum by using the Excel. So finally, you can get the results of the tower bed on the maximum point. Okay, in this step, as mentioned before, we turn on the VTK animation. That means we already have the animation results also that's provided in this result. Now we get to the animation. Click it. And this is a jacket with the wind turbine and the real data. You can see it's on the button. This is possible to be controlled about the pan view, also isometric, or play with the animation. You can see that the wave has been moved. Okay, that is not just really the final that we have been enchanted. Just turn off it. If not turn off it, that means the program will be heavy because file is very huge. As I check on the file system on the result, it contains 3 GB already for the animation only. That's why I do not recommend to very high on the frame per second. So now we get to the axis post process. This is what we are has been enchanted by our own. Go to the output list, add the diagram category. You can see on the local force, Fx, Fy, Fc, moment Fy, Mc, or so. And even though on the displacement results of the jacket structure. Also has been included about the table that you can export the data into the Excel. So that's mean if you prefer to see on the results at the first time step, you need to go to the, here this is the first time steps already. Go to the table and then export to the Excel. It's allow you to be safe the data, like this is a displacement. So after you export it, you can open it back later on. Here you are. This is a conclusion about the U, V, W, X, Y, Z. I mean the rotation of the displacement. So at the same thing in the local force, we have been provide about the time series or so, or the table. If you prefer to see on the time series data, yes, we already provided, but if the data is very huge, it should be wait a bit, a few seconds, or sometimes it's 10 seconds or the minute. Yeah, by the way, actually to generate that is because it's very huge, it's consume a lot of the time. This is a time series data. And we can allow to choose about the location of the nodal, the total. Sorry, this is a local force, right? It's linked to the element. So we can allow to use and choose the number of elements that prefer to see the results of the local force. And this kind of the data, after you export it, can navigate to the X open fast once again, browse it into the fatigue limit state or the ultimate limit state design to the further analysis.
We are already out of time for this lecture. We only have like 10 minutes.
Oh, really? Sorry, sir.
Yeah. And then for you, because you already explained how to run the programs, then you can show some how to investigate the result quickly. So please leave me 5 minutes to finish.
Yeah, I think it's everything is already finished, sir.
Oh, really? Okay.
Yeah, because after we get the results of the local force, we can submit into the fatigue limit state or the ultimate limit state design, sir.
How long does it take if you show the result for the fatigue limit state analysis?
Oh, very long, sir.
Very long.
Very long, sir.
Okay. Okay. Thank you very much for your lecture. And you started starting from the menu and then the model development and the analysis. You covered every aspect of running the X-wind. So let me summarize what we did today. 감사합니다. 오늘 저기 날씨도 너무 추워서 밖으로 다 안 나가신 것 같은데 너무 감사합니다. 다 조인해 주셔가지고. 그래서 지금 엑스윈드는 사실은 지금 오랫동안 개발이 되고 있었고요. 그다음에 이제 아까도 말씀드렸듯이 이제 김기두 교수님 그룹에서 거의 한 30년 이상 그 개발하신 프로그램에 기반이 돼 있고요. 그다음에 이제 그 해상풍력 특별 파트가 이제 산자부 연구를 통해 가지고 지난 3년에 고정식에서 했고 지금 또 이제 부유식에 대해서 지금 하고 있습니다. 그래서 이제 그 엑스피나스 IT 측에서는 이제 계속 릴리즈를 하시려고 했는데 이제 제가 그 어떤 그 전산 해석적 결과적인 측면하고 그다음에 사용자가 사용할 때 어떤 그 사용자 이슈, 뭐 컴퓨테이셔널리 그러니까 그냥 전산 이슈입니다. 그런 버그 같은 게 완전히 해결되기 전까지는 릴리스나 아니면은 이렇게 이제 통합 해상풍력위원회에서 그 강의 형식으로 이렇게 소개하는 작업을 제가 못하게 했어요. 그래서 제가 계속 브레이크를 잡고 있었던 경우고요. 지금 고정식 같은 경우는 이제 여러 경로로 확인했습니다. 오아리 캐터펄트사 영국에서도 지금 인증 보고서가 왔고 저희 연구실에서도 이걸 가지고 지금 굉장히 인텐시브하게 지금 사용을 해가지고 지금 이제 아무 문제가 없는 걸로 제가 확인을 한 상태라 오늘 지금 이 자리를 만들었고요. 그다음에 지금 오늘 저기 만들어진 그 링크에서 그 다운 받으시는 그 프로그램은 지금 2개월 프리 라이센스 그 2개월 프리 라이센스 그 코드입니다. 그래서 그거 가져다가 그 2개월 동안 그냥 프리리 좀 사용하셔도 될 것 같고요. 저기 김 교수님, 그게 2개월이 오늘부터 2개월인가요? 그거 마이크 좀 키셔야 됩니다.
다운로드하고 나서 사용한 날짜부터 2개월입니다. 그리고 대학 및
그러면
교육령은
그러면
계속해서
저
무료로 사용할
교수님
수
그러면
있습니다.
그거 다운로드 받아가지고 복사본 가지고 있다가 또 하면은 2개월 계속 쓰는 거예요?
그 지금 한번 생각해 볼게요. 어떻게
예.
될지.
예. 그러니까 그거는 좀 확인하셔가지고 하셔야 될 것 같습니다. 아무튼 2개월 프리 라이센스고요. 저기 그 밖에 이제 사용하시다가 저기 뭐 질의나 아니면 문의 같은 게 있으시면은 이게 개발자한테 직접 가르면은 이제 되게 복잡하거든요. 그러니까 그 일일이 다 응대가 곤란하기 때문에 지금 중간에 이제 아남 컨설팅으로 지금 메일을 가도록 했거든요. 그래서 아남 컨설팅 쪽에다 주시면 그 메일을 분류해가지고 좀 개발자한테 전달하도록 하겠습니다. 개발은 주로 이제 김기두 교수님하고 여기 닥터 파신이 하고 있고요. 근데 저가 이제 어떤 특별 모듈 파트를 이제 담당해가지고 계속 구현 작업을 하고 있습니다. 그 부유식 파트도 사실은 개발은 완료가 됐는데 지금 검증이 이제 완전히 그 어떤 결과나 사용성 측면에서 검증이 제가 미진하다고 판단이 돼서 그거는 제가 설명을 미루고 있는데 상반기에는 마무리될 걸로 생각하고 있습니다. 김 교수님 저기 마무리 멘트를 한번 해주실까요?
예. 오늘 강의 들으시더라고 수고 많이 하셨습니다. 그리고 계속 지속적으로 참고 자료는 계속 이제 아남 컨설팅과 협의해서 이제 메일로 통해서 자료 업로드 했다고 연락을 드리겠습니다. 그래서 여러분들 그리고 가끔 가다가 홈페이지 보시면 최근 버전도 계속 지속적으로 업로드 되고 있으니까 홈페이지에서 다운 보시고 최근 버전 나오면 다운로드 하시면 됩니다. 이상입니다.
네, 장시간 수고 많으셨습니다. 오늘 저기 말씀드린 대로 오늘 강의 노트는요. 오늘 강의 그 동영상은 지금 화면 공유하시는 여기 제가 지금 연구실에서 이제 다양한 용도로 뭐 세미나라든지 그다음에 연구실에서 자료 교환할 때 여기 그 웹 유튜브 채널에다가 자료를 올려놓는데요. 저희 해상풍력위원회에서 세미나 하는 것도 여기다가 다 올려놓고 있습니다. 그래서 필요하시면은 그 이 동영상 자료는 추후 참조하실 수 있도록 제가 하겠습니다. 그리고 참조하실 때 구독, 좋아요 잊지 마시고요. 자, 그럼 오늘 강의는 여기서 마치도록 하겠습니다. 감사합니다.